So welcome to another video of Smart Pathshala. So in this lesson we will study about determinants. Okay, so as you can see here, there are two equations and we have the solutions for x, and simultaneously if you equalize them we'll have b1 by a1 equal to b2 by a2, and that if you simplify you can get this equation, and this equation can be represented in such manner, and this is also having some value which is 0. Now remember, we are having in the previous chapter such type of matrix. This is called, we are used to call it 2 by 2 matrix. Similarly, we will call it a determinant of order 2. Fine. Now, the main difference between matrix and determinant is that matrix is an arrangement while determinant is a value. Okay. Now, this must be a square matrix always. Okay. Now, we'll see a 3 by 3 determinant. Okay. Let's see, we are having a determinant that is a1, b1, c1, and similarly a2, b2, and c2, and in the third row we have a3, b3, c3. Okay, now that is a square matrix. It is a square matrix. It is a square or a determinant of order 3. Okay, now it is an important term, minor. If we are asked to find the minor of a1, then obviously eliminate the column and rows, and the remaining element will be represented as determinant and as the minor of that element. Fine. And we know this arrangement value, that is b2 c3 minus b3 c2 or c2 b3. Okay. Now similarly, if you are asked to find the minor of b2, you must cancel the column of b2 first and then cancel the column of cancel the row of b2. Fine. And then we will be remaining with the other elements. Write it within the determinant and find the value of this determinant. This is a1 c3 minus c1 a3. Now another term is the cofactor. In cofactor, we are having the sign for every position. The sign are written for the position as, suppose d is equal to, suppose that this is a 3 by 3 determinant. We are having plus minus plus, minus plus minus, and then plus minus plus. Okay. Now how is this positioned? This is having a formula when I and j have, I is the row and j is the column, and we determine it by minus 1 to the power I plus j. Okay, hope you understand. Okay, now let's say we are asked to find the cofactor of any of the element. Actually, cofactor is nothing but the multiplication of the sign of a position and that minor of that position. Okay, fine. Now let's say we are finding the cofactor of a2. Then what is the sign of a2 is minus. Fine. And then the cofactor of a2. Cofactor of a2 is, first eliminate the row and column of a2, and then we'll have b1 c1 and b3 and c3. Okay, b1 c1, b3 and c3, normal. Now that is cofactor of the determinant. Fine. Okay, now we'll see the properties of a determinant. There are various types of properties of a determinant, and mostly we will use such properties of determinant while solving the problem. Suppose you are having a determinant a1 b1 c1 and a2 b2 c2 and also a3 b3 c3, and you are interchanging the rows and columns. Okay, then the row will become column, that is the first row become first column, second row become second column, third row become third column. Like in that way you have done the transpose of a matrix. There is an analogy here. So in that case the value of the determinant will remain unchanged, that is they are equal. Similarly, suppose you are having a determinant a1 b1 a2 b2, and that will be equal if you interchange the column. Fine. And also if you interchange the rows, this will give the same result. Only the thing is that you have to put the minus sign in the front. Okay. Now another one is, suppose you are having two similar rows or two similar columns. In that case, if you have two similar rows or two similar columns, then actually the value of this determinant will be 0. Okay. Now the fourth property, which maybe is one of the most important property, is that suppose you are multiplying some scalar into the determinant, then either it is multiplied in only one row or in only one column. Okay, now in matrix we have seen that if you multiply one scalar, then obviously that scalar is multiplied to each and every element, but in determinant it is not that case. It is either multiplied to the elements of any one row or any one column. Similarly, if you have an determinant like this, a1 plus lambda, a2 plus lambda 2, a3 and a4, then you can write it in a separate way, a2 a4, and then you can write lambda 1 lambda 2 a3 and a4. Fine. Okay, so these were the different types of properties which you must need to solve the problems of a determinant. Fine. Okay, now let's say we are having a determinant. We are asked to evaluate the values. We are having the elements as a square pc, ac plus c square, a square ab, b square. Fine. Then we are having ac. Fine. In that way you need to find the value of this. Okay, now you need to apply the properties that we have discussed earlier. Remember, this is not a very preliminary type of example. This you can achieve after going through some easy problems in your book. So I recommend everyone to just go through their books, first the easy problems, and then you will come through this. But it's good for understanding in this video. Okay, now say we will apply some elementary operations according to the properties. That is, if I change r1, sorry for your inconvenience again. Now that we have to find the value of this determinant, we will apply some elementary operations. So we have r1 changed to r1 plus r2 minus r3, which will give us 2a square plus ab, and then ab. And in the second column we have b square plus bc, and ac and c square, because they will remain unchanged, because only the operation that has occurred is the first row. Fine. Okay, now in the first row we have, fine. Remember, this is actually the application of the properties of determinant, nothing more than that you can do. Okay, after this you have 0, and in this case you will have 2 ac. Okay, now remember, in case of matrix elementary operation, we used only row operation or we used only column operation. In this case you can use both row or column in the same problem. Now from this case we are taking a, b, c common from column 1, column 2 and column 3, and then we are left with this determinant. Okay, fine. Now we can see clearly that this column 1 and column 2 are having two similar elements. Okay, this is 2a and another 2a. So if you subtract this column 1 and column 2 from each other, then you will get a 0 element. Now that is actually ultimate goal, to attain two zeros in the same row or same column, so that you can expand along with that row or that column. Okay, fine. Now let's apply some elementary operation. Suppose we are changing c3, and c3 changed to c3 minus c1, and you are having abc, and that gives 2a, a plus b, b, and c2 will not be having any change, having 0, minus b, and c minus b. Fine. Okay, now you can expand it, because you have the first row 2 elements as 0, so that you can expand it. Only you need to write is 2a, that is multiply first b into c minus b, so that you get bc minus b square, you get minus b plus c. Now that you have a minus sign over there, Yeah, so just put it into bracket, b plus c. Fine. What you need to do is the simplification. That's pretty much easy. So you have bc minus b square plus b square plus bc. Okay, so here obviously you are having, so there is 2bc, so you have 4 a square b square and c square. So this is the result. Sometimes it is given in the book that prove that this stuff is equal to 4a square b square c square. Now this can be found in NCERT book also. Okay, now the another problem, let's solve it. Suppose you have a determinant x y, x plus y, and y, x plus y, and then x, and you are having x plus y again, and x and y. Now pretty much simple problem this is. Okay. Now we need to, the main ultimate goal is to find 0. Okay, now say we are adding the column or the rows. Okay, what we are getting is 2 into x plus y. Okay, so add them, either you add row or you add column. Let me add all the rows. So we have r1 change to r1 plus r2 plus r3. So what I am having is 2 into x plus y. Similarly here also 2 into x plus y. Similarly in this case also 2 into x plus y. Fine. And I don't have any change either in the row 2 or in the row column. Sorry, in the row 3. Okay. Now here you take the 2 into x plus y common out of that, and you have 1 1 1 y, x plus y, x plus y, x y. Fine. Now what do you need to do? You have 1 1 1 up there. Okay, now you just have to subtract them to convert them into zeros. That's it. C2 changes to C2 minus C1, and then C3 changes to C3 minus C1. Fine. Then 2 into x plus y, and the C1 will remain constant as same. Okay, now you are subtracting C2 from C1, sorry, C1 from C2, so that you can get this result. Fine. Now expand it with along row 1. You have only one element there, and that is 1, so that it is obvious that you will write 2 into x plus y into 1 into minus x square minus of minus y into x minus y. Fine. Okay, now what you are having is 2 into x plus y to minus of x square plus xy and minus of y square. Okay, now remember what is this form. Take the minus out of that bracket. You have minus 2x plus y into x square minus xy plus y square. Now that is obviously the formula of x cube plus y cube. Fine. Okay, minus 2 remains the same, so you have x cube plus y cube. Perfect. So this is the solution of the determinant. So I hope you guys have enjoyed it a lot, and if you like the video, share and comment us your doubts. In the next video we'll study about the inverse of matrix, to find out the inverse of matrix using the determinant method, and to solve some problems using Cramer's rule. What do you say? Okay, so in this way we'll continue with the determinant and matrix playlist. So stick with us, and also suggest us some procedures by which we can improve more. Bye, see you, thank you for staying us this much long, and okay, see you in the next video. Please subscribe and comment down.